Okay, today we are seeing the higher order linear differential equation with constant coefficient. So example is here of that. Solve d square y by dx square minus 2 times of dy by dx plus 2y equals to sine hx plus sine root 2x. Okay, here there are two functions. This sine hx is the hyperbolic sine because h is there. Okay, sine root 2x is here. This is the circular sine. That is the difference. Now we just have written the here equation. After that, our first job is to find out the symbolic form. For symbolic form, I just take the ddx as a d. So now equation will be written as d square minus 2d plus 2 y taken outside equals to the RHS part as it is. Next job, we calculate auxiliary equation. For auxiliary equation, in this function of d, I replace the d by m. I get that it is m square minus 2m plus 2 equals to 0. Finding the root of this quadratic equation, that will come out to be 1 plus minus I. Imaginary roots are, they always occur in pair. Okay, one root is 1 plus I, another is 1 minus I. I equate this quantity with the alpha plus minus I beta, because we are having a method, that is a way to write down the complementary function for imaginary roots, and that complementary function will be e to the power alpha x. If you compare, alpha is 1, therefore e to the power x, then c1 cos beta x. If you compare, beta is 1 here, that is coefficient of I. So it will be c1 cos x plus c2 sin beta x, again beta is 1. Now this is the complementary function for this differential equation. Next, we find out the particular integral. It will be given by 1 upon that function of d. That is the function of d we are having. Okay, this we have written here into the RHS part. Is it okay? Now further, I distribute this operator over these two function, alag kar diya, and then here it is a sine hx. So we haven't seen any cases to solve a sine hx. That can be solved by the general case, or maybe we can we have a relation actually in between this hyperbolic sine and the exponential function. So that relation we will use here. So how to get that relation? I just listed here that two formulae of sine hax and cos hax. Sine hax ka formula it is a relation between the exponential function and hyperbolic sine and cosine. Okay, the relation is what? For the sine hx, e to the power ax minus e to the power minus ax by 2. You just note it, minus is here whenever the sine h come. अगर cos hx का formula लिखते हैं, in place of minus I just put the plus. That is the difference. Okay, now same the formula we are having for the circular sine and cosine. That is the relation between the circular sine cosine with respect to it is exponential function, and that will be given by sine ax equals to e raised to the power ix minus e raised to the power minus ix upon 2i. I is here for the sine and minus is there in between. Cos ax के लिए formula will be completely same. In place of minus it will be plus, और नीचे में सिर्फ रहेगा 2. It is not 2i. Okay, for the cos. So this is the relation we have seen in between the hyperbolic sine cosine with exponential function and circular sine cosine with exponential function. This four formulae always you remember, because many time in many examples we use this relation, okay, for simplifying the things. So here if you observe, it is a sine hx we are having, and we have written the formula for the sine hax. So if you compare, that a is 1, okay, sine hx and sine hax, a is 1. So I'll put the a as 1 in the formula. That will be then e raised to the power x minus e raised to the power minus ax by 2. Clear? Plus, now here we are having the second case, sine root 2x is here. So we apply the second case. So in that case we replace the d square quantity. Okay, so d square will be replaced by here minus of a square whenever we are having a sine ax. Okay, if I compare the sine ax with the sine root 2x, a is root 2. So we have to find out the square of a. So we find out the root 2 ka square, that will be 2 multiplied by the minus sign to get the minus a square. So we will have it as minus 2. So d square will be replaced by minus 2, that will get cancelled. We left with minus 1 upon 2d. 1 by d means it is the integration with respect to the x. Do the integration. Sine root 2x ka integration, it is what? Minus cos root 2x by it is what? Root 2. मेरा ही बच रहा है क्या? बंद करो. minus 1 by 2. Now further, here I distribute this operator over these two function, okay, and after that, this is the first case we have to apply the exponential function. Again we are having the exponential function here. D will be replaced by coefficient of x. What is it? 1. तो 1 से replace कर देंगे यहाँ पे. D will be replaced by 1. Again e raised to the power minus x. D is replaced by minus 1 because coefficient of x is what? Minus 1. Simplify the quantity. We have this one. So this is the required PI where the case does not fails. Okay, यहाँ पे कुछ zero नहीं आया है. This is the required PI. Now the complete solution will be y equals to CF plus PI. Just write down the CF added to the PI. That gives the complete solution, or it is called as the general solution for the given higher order linear differential equation. Okay, thank you.